welcome to the bonus quiz for 4.3, a section that I've warned is quite a challenging section, maybe one of the most challenging sections all semester. And that's because our unknown now gets embedded between absolute value bars, and that increases the complexity dramatically. Let me show you an idea that I think will get you moving in the right direction. Now, this is the simplest form for an equation that has absolute value in it. Y is equal to the absolute value of x. And notice how complicated the graph is. And notice too, there's an interesting mnemonic. It's a v. And absolute value is the only function I know whose graph speaks its name. It's also a v. But here's the takeaway for you that will help you in section 4.3. Notice that these two arms go off in two different directions, one to the left and one to the right. And that's the idea you need to safely navigate problems like this one right here. You need to realize that there's going to be two different paths to solution. The other idea that I think will help you here is this one, that inside every complicated problem, a simpler problem is waiting to escape. And I propose to make this complicated problem a bit simpler by doing a little bit of cover-up. And so here's the idea behind this. What values work underneath the green box there? And I think you'll agree with me that there's two. That 4 would certainly make this true. Or if this was a negative 4, the absolute value would make it positive, of course, and this would be true. Whatever underneath that box has to be 4, or it has to be negative 4. And so that allows me to translate this from an absolute value equation to two equations that don't have any absolute value in them. And so that's the game afoot, to rewrite this absolute value equation without absolute values. Now what's under this box has got to be 4, or it has to be negative 4. Okay, well let's look what's underneath that box. 2x minus 1 has got to be 4, or it has got to be negative 4. There you go. And of course, this is a section 1.3 problem. Add 1 to both sides and then divide both sides by 2 to solve for x. And the same for this one. This is from 1.3. So I know you can do those two. And when you solve these for x, the first one becomes x is equal to 5 halves. And the second one becomes x is equal to negative 3 halves. And of course, though, we still have that or. That becomes a critical feature of these. That's the symbol for a union, and it says to include them both. We see that the answer is going to be A, that in fact x has a solution. And this is roster notation, and so we would simply list these two inside there, separated by a comma. That's problem 1. Let's get on problem 2.